Alright, welcome to Pre-Calculus. This is the first lesson, lesson 1.1. And in this lesson we're going to just review different sets of numbers, relations, and functions. It's going to be quick. So, if you remember, the set of real numbers contains a variety of subsets of numbers. For example, if you take the counting numbers like 1, 2, 3, and so on, those numbers are referred to as the natural numbers, and those numbers are all a subset of real numbers. Next, if you take all of the natural numbers and you add one more number like 0, 0, 1, 2, 3, and so on, the dot 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 means it goes on forever, those numbers are referred to as whole numbers. Whole numbers include all the natural numbers plus the number 0. If you take all of the whole numbers, 0, 1, 2, and 3, and so on, forever in that direction, and you also add in the negatives, the opposites, negative 1, negative 2, negative 3, and so on, all of those numbers are referred to as the integers. And again, I hope this is review for you, so that's why I'm moving so fast. All the integers include all the whole numbers, which include all the natural numbers. And then another set of numbers in the real numbers are the rational numbers. Rational numbers are any number that can be written as a fraction of integers, like an obvious one, 1/2. That's a fraction. Also, 0.1. 0.1 is a rational number because it can be written as 1 over 10. Here's another one. Negative square root of 25. Now it looks like it might be irrational, but the square root of 25 is 5. That's negative. That's a rational number because it can be written as a fraction. Rational numbers include all the integers, which include all the whole numbers, which include all the natural numbers. And then a separate set of numbers inside the real numbers that don't include rational, integer, whole, or natural numbers is the irrational numbers. Irrational numbers cannot be written as a fraction of integers, and they include numbers that go on forever but never repeat. Here's an obvious one, pi, or square root of 2, or any number that goes on forever without a repeating pattern. Okay, so that's the set of real numbers. Remember, you can graph real numbers on a real number line. And again, this is very basic, I hope, but 1 is a real number that can be graphed on a number line. Pi is a real number, 3.14. It can be graphed on a number line. Negative square root of 25, which you found was negative 5. That's a real number. So all of those numbers in the real number system can be graphed on a real number line. You can also graph numbers in ordered pairs, remember x, y coordinates, on a coordinate plane. And if you recall, a coordinate plane is broken into quadrants, the first quadrant, the second quadrant, third quadrant, and fourth quadrant. And I'm not going to spend a whole lot of time going through all of the different parts of a coordinate plane, but just remember the quadrants are always named with Roman numerals. Every point in there is a ordered pair. Remember that some values are positive, some values are negative. And I said I wasn't going to go through all this, and I am anyway. Alright. So, in a table of values like this one, you can plot these values with ordered pairs, and usually the first row is the x value and the second row is the y value, but you make each of these an ordered pair and plot them. That gives you a scatter plot. Alright, now when you're talking about a set of values, remember there's a domain and a range. And just to refresh your memory on what domain and range are, domain is the input value, usually the x. Range is the output value, usually the y. So for this table of values that represents a person's height in inches and their shoe size, the input would be their height, and their shoe size would be, or the output would be their shoe size. So the X is the height, the Y is the shoe size. You can list each of these input, output, domain, and range values as an ordered pair, like 67 and 8.5. And by listing them in ordered pairs like that, you're defining what's called a relation. A relation is just a relationship between two values in an ordered pair. You could also write out the domain for the whole list and the range for the whole list. And remember, when you write out the domain, you just write out the values that are unique without repeating. So the domain would be 67, 68, 72, and 76. And the range, the output would be 8.5, 10, 11, and 12. You don't list each of them every single time. And now a special relationship is known as a function. And I know you've looked at functions before, but a quick reminder, a definition of a function is just a set of ordered pairs. That's a relation. But for it to be a function, each input has to correspond to one and only one output. That means there can't be any repeated input values that get a different output value. So let's take a look at an example and I'll show you what I mean. So here is a relation. The relation is just a list of ordered pairs. 0, 0, 1, 1, 1, negative 1, 4, 2, and so on. The question is this relation a function, true or false? Yes or no? So to determine whether a relation is a function or not, the easiest way is to look at the x values. And if there's a repeated x value, like there is right here, the x is repeated. If it has a different output or y value, which these do, then it is not a function. Okay, here's another one. Here's a list of ordered pairs. To determine whether it's a function or not, look at the x values. 0, 1, negative 1, 4, negative 4, 9, negative 9. In this list, there's no repeat in the x value, so this is a function. Okay, and the last example, same thing. Check out the x values. If you find a repeat in the x values that has a different y value output, then it's not a function. 0, 1, negative 1, 4, negative 4, 9, negative 9. No repeats. This is a function. Another way to think of that is graphically. To look at a graph and figure out if it's a function, you can use what's called the vertical line test. The vertical line test just means that you take a vertical line like this one and you move it across the graph. If the vertical line only crosses the red graph at one point at a time, then it's a function. Now notice that when it gets to this point right here, this open circle means that's not a part of the graph, and this circle up here is. So even though it looks like it's crossing twice, it's still only intersecting this graph once. This is a function. So you're thinking, well, what would it look like if it wasn't a function? Well, if I drew this purple graph like this, notice that this vertical line crosses through the graph here and here and here 3 times. So this purple graph would not be a function. And finally, let's take a look at function notation. Remember that a function notation is always in the form of f of x or g of x or h of x. So this part of the function is just the name. It could be any letter, q of x, z of x, and so on. The other side of the equation the x part of the function is the input number. That's the domain. So this is what you put into the function. This part is what tells you what to do with the input value, and what you get out is the output number. So if I wanted to figure out what f of 2 is, that means 2 is my input value. I'm going to put 2 in place of x in the function. 2 squared plus 1. 2 squared is 4. 4 plus 1 is 5. I get out square root of 5. 2 is my input. Square root of 5 is my output. And that's where we're going to stop. That's just a quick review of real numbers, relations, and functions. And now you can move on and do the assignment that's associated with this video. Good luck.